Hey there, today let's try to solve another LeetCode problem. So today the problem title is minimum cost to merge sorted list. So you are given a 2D integer list where each list I is a non-empty array of integers sorted in non-decreasing order. So basically it's like a nested list. You may repeatedly choose two lists A and B where the index is not the same and merge them, and the cost to merge them is A and B is the length of A plus the length of B plus the absolute value of medium A minus medium B. So basically it's the difference between the two mediums for the two lists that you selected. And after merging A and B, removing both A and B from the list and insert the new merged sorted list in any position and repeat merges until only one list remains. And return an integer denoting the minimum total cost required to merge all the lists into one single sorted list. The medium of an array is the middle element after sorting it non-decreasing order. If the array has an even number of elements, the medium is the left middle element. So this is, I guess it's one tricky part, because usually when the array has an even number of elements, the medium will be the left middle plus the right middle divided by 2. But this time we will just pick the left middle. Okay, and yeah, let's take a look at the example. So the list is 1, 3, 4, 5, 2, 4, and 6, 7, 8. Let's see why that is the case. Okay, so the input is this. So again, we can merge this one and this one, and the cost will be, the length is 3 plus 2 plus the medium is 3, and the medium here for this array is just 2 because we just choose the left middle element. So it will be like this. It's not plus, it's we need to take the absolute difference of that. So it will be like 6th, because 3 plus 2 plus 1 is 6th. Okay, and then after merging, the array will become something like this. We merge the first two, so it will be like 4 will become something like that. And then now we have only one choice. We have to merge these two lists. This one, let's copy them. So this has 5 elements plus 3 elements plus the absolute difference of this one is 3 minus 7, I guess is 4. So it's 4 plus 3, which is 7. 7 plus 5 is 12, right? Yeah, it's 12. So after that, the whole thing is merged because there's only 2 remaining here, and everything will be merged. After this operation, then we're done. And the total cost of that is 6 plus 12. So that's why we should resolve in 18. There are different ways to do it. For example, first time you just you don't merge 1, 3, 5 and 2, 4. You may merge 1, 3, 5 to 6, 7, 8. But you can try that, and you will see that it's no less than 18. So that's why you kind of brute force every pair, then you will know the optimal answer is 18. Yeah, that's pretty much all for the problem description. And another thing you notice in terms of the problem description is that you can notice the list size is pretty small, and yeah, even the nested size, like the outer array is really small, like 12, and even if you count the elements inside the nested list, it still will not be over 2000. So that's another thing you have to note for in terms of the problem description. Okay, yeah, that's pretty much all for the problem description. Let's think about how can we solve the problem. So how can we actually solve the problem? So if you take a look at the list size, which is the outer list, you will notice there's only like 12. So whenever you see something like 12, I guess it's pretty obvious that you should somehow make use of bit masking, because 2 to the power of 12 works pretty safely in bit masking. And there's no way the solution will be like n square, because n square is still pretty small. If the optimal solution is something like n square, then they wouldn't make the limit as 12. So the fact that they make the limit as 12, it kind of hinted you that you should either use bit masking or some like permutation stuff to solve the problem, because yeah, again, otherwise if there's a more optimal solution, the size limit wouldn't be that small. So that's just one hint. It doesn't necessarily true for everything. Maybe they just don't want to set the input size too large for some reason, but it's just like a good hint whenever you consider the input size. So how can we actually solve the problem? Let's think about how can we use a recursive function to solve the problem? Well, let's assume we have a bit mask, which stands for, like, let's say if it is like 1 0 1 0 1 0, and the list is like something like this, like array 1, array 1, array 2, array 3, so on and so forth. Let's assume that I have a bit masking, like a binary number, to represent the state that we want to solve. For example, you can see like the first like number is on. That means that we consider this one. We consider this sublist. So this bit mask, which will represent a list, equals to something like array 1, because this is 1 and this is 0, then we don't consider that, and this is 0 as well, we don't consider array 3, so we're just gonna array 4, and this again is array 5 is 0, so we don't consider that. Array 6 is 1, so we consider that. So now if we are thinking bit masking in this way, so each binary number will just represent like what is the like a subsequence of list that I want to solve. So obviously, if that's the case, then we will have something like DFS, and then bit mask. So minimum, this is the DFS bit mask, will be the minimum cost to merge subsequences in list based on bit mask. So again, then we have, whenever we think about DFS, we have to think about some base case. So what are some base cases? Well, if you think about it, let's assume there's some bit masking like 1 0 0 0 0, and that will represent to just array 1, right? It has nothing else because everything else is turned off. So that's why if like the bit count of bit mask equals to 1, then we just return 0 because there's no cost needed to merge. All right, whenever you do bit mask, anything outside of the mask, we just consider them not existing. So in order to merge anything that within this bit mask inside the list, and because there's only one list inside here, so again, then we should just return 0 because there's nothing to merge. So another base case is if bit underscore count bit mask is equals to. So what does that mean? So for example, it can be 1 0 0 1 0 0 0. It could be something like array 1, and then 2 is off, 3 is off, and 4 is on, and everything else is off as well. So if you look at this this subproblem, there's only one way to solve it. There's no choice for us to make. We can only merge array 1 and array 4. So we know how to do that. We just get like ij equals to get on bit, like something like that. Is pretty easy to do. We just loop every bit and just count the number, the first on and the second on. It will be I and j, for example, and then we know how to do that. It's just return median of I and j, and then medium of list I minus medium of list j, and then we need to get the absolute for that, and plus like list I size plus list j size, because yeah, again, we don't have any option when there's only 2 array in the bit mask. We have to merge them, and this is the only way that we can merge them. So then we handle all the base cases. Let's think about something more complex. So what if they are not, what if the bit count has more than 3? Then, well, we need to think about what is the last step. Okay, so assume it could be something more complex here. Let's take a look at this example. Let's 1 0 0 1 0 1 0. So we just need to think about what will be the last step. So you can merge 4 and 6 first, and then it will basically be like array 1 merging with array 4 and array 6. And it doesn't matter, it just consider them merged. What is the minimum way to merge them, and what is the minimum way to merge this? So after doing those, then we will just merge these two, right? So here we just need to, for the more like induction, there will be just like calculating brute forcing. I would like to call it brute forcing. What is the last pair to merge? Because no matter how you merge them, well, again, you can do something like this: array 4, array 4. So no matter what you do, there's has to be the last pair to merge. So now we just brute forcing what is the last pair to merge. So how can we do that? So we just for mask A, for example, which is the one that we're gonna merge in like 1 2-bit mask. Then we do some like basic checking. For example, if mask A and like bit mask is not equals to mask A, it's just some basic checking, then we just continue. It means that mask A is having some bits on that does not exist in bit mask. So basically, I have to make sure mask underscore A is a subset of bit mask. If it is not, then we just continue. And then mask B will be like, because we already choose mask A, so anything else that does not exist in mask A, then we will like, it will be it will be bit mask XOR mask A. So this, why this works, this is because like, again, like mask A is a subset of bit mask. So when bit mask XOR mask A, because they both turn on, then they will be off. And for something that appear in bit mask but does not appear in mask underscore A, they will be on. And that is exactly what we want to capture in mask B. So as a result, mask just mask A and mask B will be equal to 0. And mask A or mask B will be equal to bit mask. That's what we're trying to achieve here. And then now we want to reverse every possible last pair to merge. And it will be something like this. Let's say merge. So merge mask underscore A and mask underscore B. So this is a little bit more tricky. For example, if you want to merge some subarray here, you can just iterate every number and then get the medium of this. For example, 1 and 4. What happens if they are merged together? And then once we have the size and the medium, then we will be able to do this formula to do this merge. So we have to do some pre-calculation for the merge, but after we have done the pre-calculation, this whole thing will be O1. So it won't be too time consuming for us. And we also, of course, we also need the DFS of mask A plus DFS of mask B. And this will be one possible answer, and we have to brute force every possible pair. And once we have brute force every possible pair, then we can kind of know the optimal solution for that one. So answer equals to like minimum answer, that one. And finally, you just return answer. That will be our final solution. Yeah. So yeah, that's pretty much all for the intuition for the solution. And let's see how can we actually implement that. Okay, so let's get started. First, before we begin our main function, we need to write some helper method first. First one is going to be the medium, which will take an integer array, and we will just return the medium given the array is already sorted. So first we get the size, and if n is 0, we just return 0. And if n mod 2, it means this is odd, then we'll get the middle one. If it is not odd, that means it is even, then we take the left one, as we discussed before. And then we also need another helper method. Let's call it get on bits. So this function basically will take a mask, it will just return every position where the mask is on. For example, it could be 10010, and then it will turn like 1 should be in the result array and 2 is not, 3 is not. So 4, it should return like 1 and 4 in terms of the on bit position. Yeah, that's pretty much what this function will do. And later on, we will use this on bits to like know what index that we should consider inside the list. So let we just implement that now. Result, and then I equals 0, I less than 31, I plus plus. If mask, and if this bit is on in the mask, then we just push this index to the result, and eventually we just return result. So now we have those 2 helper method. We actually need one more. Let's just call this int2. We need this method that will be called get medium and also sized. So vector, and so it just basically just take the input list and also the mask, and we just want to know, given this mask inside this list, so basically a subsequence of list based on the mask, I want to know that subsequence list, the medium and the size of that subsequent list. So we just need to list here, and then for every indexed for the list sized, if this bit is on, mask and 1i, then just for every value here, then we just push back this x here, because this is part of the list. We just want to merge everything, and then after merging everything into one list for this subsequence, we just sort them using the C++ utility function list end, and then we are going to return, let's say the first index is going to be the medium list, and the second index will be the size of the list. We just do it something like this, list.sized. We do that because this list.size in C++ is not an integer type, it's size underscore t type. So that's why we have to cast it to int in order to fulfill the return type here. It's such a C++ thing. It's not kind of related to the problem. So now we are ready to actually write our function. Let's head back here to what we have discussed before in the intuition section. So if it is b count is 1, then we should return 0. If it is b count is 2, and we do this, and otherwise the induction step is something like this. So we're going to follow this. Let me just copy this thing to the main function here. This is what we're going to do. Okay, paste it here. So first, we are going to know the int, the size of the outer list, and we also need the total bit size. You know, the total bit size will be something like 1, and eventually we want to return something like we want to return something like 1 left shift n times -1, because imagine we have like 3 element, And then if we just left shift 3 times, it will be 1 0 0 0. And then -1, if do -1, will become 1 1 1. So 1 1 1, what does 1 1 1 mean? So dp 1 1 1 is just the minimum cost to merge everything, basically, in list. Because 1 1 1 means like turning on every sublist. So the subsequence of 1 1 1 1 1 is just list itself. So that's why eventually we want to return something like that. Let's get back. And then we need to pre-calculate the medium and size so we can like save some time for the actual calculation. Let's do it mediums, and then length, and then sized length. And then for each mask, start from 1, mask less than length, mask plus plus. So the result, we're going to use the helper method that we have written on top, medium size list, and then mask. So once we have this result, and then we're going to restore the pre-calculated value, where's 0, mediums, mask, where's 1, and then we just write a short helper method, merge. This merge method will basically just take 2 masks, mask A and then mask B. Because we have this pre-calculated value, we can very quickly calculate or know the result of this merge. This basically is just what we need to do here. Let me scroll up a little bit. This part for merging mask A and mask B here, we're just going to implement that. First, we need to know the mediums of mask A minus mediums of mask B, and then plus the size of mask A plus the size of mask B. And then we are going to write this dp. The dp size will be length as well. And then we're gonna loop for some mask. For now, we don't care. For now, here, let's scroll back up. We need to implement this base case first. So here, let me change to C++ index, C++ syntax. So in C++, we can do something like beatcount. Beatcount equals to underscore built-in underscore pop count mask. This will tell us the beat count of the given mask. So if the beat count is 1, then we just return 1. So return 0, sorry. So it would mean dp mask equals 0, and then continue. And then this one, bit count, let's say it's 2. And then we need to get 2 on bits here. So let's say on underscore bits equals to get on bits for this mask. And then we will just actually we can just do the merge here. We can reuse our merge, and then 1 on list 0, and then 1 on list left shift 1. So this will just merge. So because we only have 2 armed, now it will just merge the first occurrence and the second occurrence. So this won't overflow because we already know that bit count is 2. So here we'll just dp mask equals to this one, and then this one is continuous as well. To just simulate the return syntax in a recursive call. And otherwise for this, let me copy that again. We're just gonna brute force all the possible last pair to merge. So again, let me change to C++ syntax. This is 1 all the way to mask, and then mask A++. Do that, and then we do a check here. There's not much we need to change. So basically this one is to make sure mask A is a subset of bit mask. So if it is not, then we just don't consider that. But if it is, then we also want to know the mask B, because we have to merge mask A and mask B in order to solve the current bit mask. Right, so it should be mask. And then this DFS, we just change it to DP now. And this DFS change to DP. And then we are done. We just return that. So DP mask equals answer. And we remove this empty line. And yeah, let me double check if I have missed anything. So let me remove this comment. Oops. Okay, let me try to submit that and run the sample test case. Okay, we are missing this. So we need to decide the order of mask. So, and also I'm missing a semicolon here. So we need to consider the order of mask. So what do we reference our previous value? From here, we'll know whenever we are calculating the answer for mask, we want mask A and mask B to be ready. So what is the relationship between mask A and mask B to mask? Apparently, mask A and mask B are both subset of mask, and they are strictly less than mask. Both of them are. So what I'm trying to say is that this DP value will always be smaller. The one that I'm trying to access must be smaller. So that's why it is safe to start from the smallest possible and work our way up to the largest possible. And yeah, that should be it. I mean, there's a lot of missing semicolon. Let me add that as well. And let me try to rerun the sample test case. Bit mask should be mask. merge answer. Okay. Okay. So this mask, I have to initialize this mask. Just initialize that as the infinite value here. Let me do that again. Let me try to run the test case again. Okay, there's some wrong answer. Let me check if I have missed anything. Okay, this should be sized. Sorry about that. Let me try to run the test case again. Okay, and let me try to submit. Okay, accepted. And so the time complexity for this solution is, so this one is O1 to the 2, basically 2 to the power of n, and then we do another pop count here. It will be like n, because you have to iterate under the hood. You have to iterate the bit mask in order to get the bit count, and also sometimes I would do the on bits as well. And then we also need to iterate this again. So this is basically another 2 to the power of n. So plus 2, something like this. This should be the total time complexity. That is for the time complexity. Time. And for the state complexity, it will just be this one to the power of n. O to the power of n. Okay, let me put it here and place it here. Yeah, that's pretty much all. And I will see you in the next one. Thanks for watching. Bye.